Hello, I'm David Imrie, Chief Technology Officer at Optikos, and I'm delighted to introduce you to the TM1010, the latest member of our ever-expanding family of thermal modules for lens testing. Over the last few years, Optikos has pioneered the development of thermal chambers that enable lenses to be measured over the range of temperatures that they may be expected to encounter in their real-world applications. Although they were initially developed to satisfy the testing needs of the automotive camera sector, these thermal modules are increasingly being used to also test lenses for consumer products and for the defense industry, all of which must perform to exacting standards under extreme temperatures. The thermal module line is a good example of a product that has its roots in our IQ Lab, first developed for IQ Lab customers who specifically wanted their lenses to be tested at very low temperatures. Because of increasing interest and demand in this application for both IQ Lab and product customers, we further developed the line for commercial use by our clients in their facilities. The TC1010 is a thermal chamber that is intended for use with small form factor, wide field of view lenses. Larger lenses may be accommodated by the TC1050. Both are adaptable for use on the lens check or an op-test system. Very large lenses must be accommodated by the TC1150, a thermal chamber that must be mounted on a full-size op-test bench. The setup we have here shows a TC1010 on the lens check. At this point, I should probably explain our naming convention. Unsurprisingly, we call the chamber in which the lens is mounted the thermal chamber and give it a TC designation. But there's more here than just the thermal chamber, and so we refer to all the bits and pieces that together constitute a complete system as a thermal module. So a TM1010 thermal module consists of a TC1010 thermal chamber and several other components that are common to all of our thermal modules and at which we are now going to take a look. The roles that these other components play are best understood by considering how it all works. At its core, the system sets the temperature of the lens under test by mounting it within a cylindrical heat exchanger. The temperature is regulated by circulating a thermal fluid through a cavity in the walls of the heat exchanger. The temperature of the thermal fluid, in turn, is regulated by this thermal controller. The operator can set the temperature from the touchscreen on the front display, but in most applications, it will be the op-test 7 software that is sending instructions remotely to this controller. The fluid circulates from the thermal controller to the thermal chamber in a closed-loop manner through two insulated hoses that you see here. If the lens were to remain fixed on the test bench, we could simply drape these hoses along the table. But because we might want to make off-axis measurements on the lens, we must permit it to rotate. It is for this reason that the hoses enter the chamber from above, so they can be placed as close as possible to the axis of rotation of the platform on which the lens is mounted. This is the function of the self-supporting troughs that you see here, in which we affectionately refer to as the skyhook. They guide the hoses down into the thermal chamber from above, from a height that is sufficient to support the wind-up that occurs when the lens rotates off-axis. It is generally a rule with any metrology equipment that the apparatus itself cannot affect the measurement being made. In the case of lens measurement equipment, this means that we cannot introduce something into the optical path that will affect the performance of the lens under test. On the input side, where the light is collimated, we can and do place high-quality flat windows, but this is not true at the sharp end where the image forms, because doing so would introduce spherical aberration. So we cannot seal the image side of the chamber. An obvious consequence of this restriction is that condensation will form on the lens under test as soon as the temperature drops below the ambient dew point. That's where this module comes in. This is the CM1000 control manifold, and it performs several functions, but its main purpose is to regulate the flow of dry air into the thermal chamber. Customer-supplied dry air enters the manifold from the back. In our case, we're simply using the commercial 2-column air dryer to reduce the dew point of the shop air to negative 40 degrees. These rotometers along the front panel incorporate needle valves that the user can set to predefined flow rates and then a series of remotely controlled valves commanded by the Optikos 7 software turns the air onto specific channels at preset temperatures. The air flows out through these colored tubes and enters the chamber from above, where it is directed to where it is needed. In this way, we are able to maintain a dry atmosphere over the windows and around the lens under test. The control manifold also performs a few other functions. It measures and reports the ambient dew point. It measures the temperature of the lens under test. You see here where that probe connects. It controls the mechanical shutter in the thermal chamber, as well as the internal illumination. All of these functions are controlled remotely by the Optikos 7 software, but they are also manually controllable from the front panel. And so we finally arrive at the thermal chamber itself. By its very nature, it does of course require thermal insulation. For ease of access to the interior of the chamber, this insulation is held in place magnetically and is readily removed. In the case of the TC1010, there are 3 pieces of insulation that we will now take off and put to one side. Notice that I need to pull back the image analyzer to remove the back piece. But there is a finely adjustable stop in the base of the unit that allows me to return it to its previous position. We are not now looking at the heat exchanger, but instead at a hard shell that provides an additional layer of insulation and protects the operator from making direct contact with the heat exchanger. Of course, operators should always return the temperature of the thermal chamber to within a few degrees of ambient before opening it to retrieve or restore the lens. We can see how the chamber mounts to the optical rail in place of the usual lens mount. The pitch and yaw controls that are required to align the lens to the collimated beam are incorporated into the base of the unit. The operator locks those controls with this knob after making the necessary adjustments. Although we cannot place an optical window in the convergent light path, it makes sense to close the chamber while the lens is undergoing a change in temperature, and to open it only for the time actually needed to make a measurement. This is achieved through a mechanical shutter, which we see opening and closing. The lens is installed through the front of the chamber by first removing the window assembly. This has a simple bayonet-style latching mechanism, but you will notice that there is a cable attached to the window. This is used to control the brightness of LEDs that are used to illuminate the interior of the chamber. We shall discuss their purpose shortly. The TC1010 has 2 defining characteristics: the shortness of the chamber and the construction of the front window. Together they ensure that the entrance pupil of the lens under test can see the widest possible field of view. The window itself consists of a high-quality double-paned segmented window. This necessarily means that there is a small blind spot on either side of the optical axis where the segments meet, but its effect is relatively small in the case of the wide-field lenses for which this chamber is intended. At last, we have peeled back the layers of the onion and have arrived at the lens itself, and it is time to address the question of how the lens is mounted to the heat exchanger. As you may have expected, this requires fabricating an interface plate specifically for the lens to be tested. Only by doing so can we ensure a good thermal contact from the lens to the heat exchanger. Customers typically design and make their own interface plates, but Optikos can certainly do this for them. The form and outer bolt circle of the interface plate are of course standard, but the details of how the lens interfaces to the plate will vary according to the form of the lenses, the material from which it's made, and the options for attachment. Quite often, the parameter of greatest interest is simply defocus. In other words, is the design of the lens assembly correctly thermalized? To determine this, we measure the variation in the flange focal length of of the lens as a function of temperature. In other words, at each temperature setting, we measure the distance from a mechanical surface on the lens to the image plane. Finding the image plane is easy. We simply use the Optikos 7 software to perform a through-focus MTF measurement and then move to the plane of peak MTF. The tricky part is to find the plane of the lens flange. This has to be established at each temperature setting because it is likely to move with respect to the image analyzer coordinate system as the temperature changes. The technique we use is to build into the lens interface plate a means of holding two patterned reticles, which are these white squares, in the plane of the lens flange. I won't go into the details of how this is done, since there are several tricks that must be employed to ensure that the surrogate datum is itself athermalized. But once the reticles are in place, it is a relatively straightforward matter for Optikos 7 to locate them in the same way that it locates the plane of best focus. And now you can appreciate the need for the LED illumination we saw earlier in the windows. It is used to back illuminate these reticles. That brings us to the end of our brief overview of the new TM1010 thermal module and some of its patent pending features. You will appreciate that there is a fair bit more complexity to making thermal lens measurements than is the case for making lens measurements at room temperature. So if you have any questions, please contact us at Optikos and we'll be happy to answer them. Thank you.